Classification of matter, elements, compounds, and mixtures. This chart shows how matter can be divided into three main groups. The first are elements. Elements are made of atoms that are all alike. There are currently 118 elements found on the periodic table. The second group of matter are compounds. Compounds are made of atoms of different elements chemically bonded together in a fixed proportion. There are over 20 million combinations of elements that go into making compounds. The third type of matter are mixtures. Mixtures are made of matter that is physically mixed but can be easily separated. Because there is no fixed ratio, there is an infinite number of mixtures possible. This analogy gives a good example of how elements, compounds, and mixtures are related. We can represent elements by the individual nuts and bolts in this picture. When those nuts and bolts are combined together in a fixed proportion, we get a compound. And those compounds and other pieces and other nuts and bolts and other things are mixed in together and thrown in together, we have our mixtures. Elements are the simplest form of matter. Everything in the universe is made of elements. Hydrogen makes up 99% of the universe. Elements are made of atoms, which are similar. Atoms of different elements are different. There are currently 118 elements. Metals, nonmetals, and metalloids. So this is a picture of the periodic table. Notice that the green elements are the metals, the orange or tan elements are the nonmetals, and this blue section right here that is between the metals and nonmetals are called the metalloids. There are certain elements that are called diatomic elements. The smallest part of an element is an atom. Some elements have atoms that are always arranged in pairs. We call these diatomic elements. Di meaning two, atomic meaning atom. You must memorize these 7 diatomic atoms, or 7 diatomic gases rather. They are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and astatine. Notice that these atoms are always combined together in pairs. Compounds. Compounds. A chemist defines a compound as a combination of 2 or more substances chemically combined with new chemical and physical properties. Compounds have a fixed composition. The amount of each element in a compound is always the same ratio. In water, the ratio of H2O is always 2 to 1. Mixtures. A chemist defines a mixture as a combination of 2 or more substances in which each substance retains its own chemical and physical properties. In general, mixtures have no fixed composition. The amount of 1 or more components can usually vary over a wide range. Mixtures can be easily separated. There are 2 main types of mixtures. A homogeneous mixture is a mixture in which the particles are evenly mixed. Solutions and colloids are homogeneous mixtures. Homogeneous mixtures do not appear to have 2 different types of particles to the naked eye. For example, air, milk, salt water, colas, iced tea, fog, and smoke. Those are all examples of homogeneous mixtures. They look mixed, they look uniform, but there are really 2 or more particles that make up those mixtures. Heterogeneous mixtures. Heterogeneous mixtures are mixtures in which the particles are not evenly mixed. You can tell that there is a mixture because there is usually 2 visible phases present. Suspensions are heterogeneous mixtures. A suspension is a heterogeneous mixture in which the particles are big enough that they will settle to the bottom if they are let to stand. For example, Italian salad dressing is an example of a heterogeneous mixture. Blood, dirt, orange juice, ketchup, and mustard are all examples of heterogeneous mixtures because the particles are large enough to settle out. Homogeneous mixtures are also called solutions. Solutions are mixtures in which the solute particles are smaller than 1 nanometer. 1 nanometer is 1 times 10 to the negative 9th meters. These particles are so small that they do not separate upon standing, they cannot be taken out with the filter, and they do not scatter light if a light is passed through them. Examples of solutions are salt water, soda, tea, alloys, and clean air. Alloys are mixtures of metals that are melted together. Although they appear to be one type of metal, they are actually mixed and blended together and can be separated easily based on the melting points of those two metals. Parts of a solution. The solvent is the matter that is doing the dissolving. It is usually the part of the mixture that is larger. Usually it is water. The solute is the matter that is being dissolved. It is usually the smaller particles that are being put into the larger mixture and being dissolved into it. For example, if you think about Kool-Aid, when you make Kool-Aid, you take the red sugary particles, those are the solute, and you mix them into the water. The water is a solvent. These are other examples of solutes and solvents. In ocean water, the solvent is water. The solute, the matter that is being dissolved, is salt, oxygen, and carbon dioxide. In filtered air, the solvent is the N2. We learned last chapter that nitrogen is the main component of air, 79%. The solute would be the oxygen, the water, the carbon dioxide. Soda. The solvent is the water, the solute is the sugar, the carbon dioxide, and the flavoring. 14 karat gold. The solvent is 58% gold, the solute is 40% copper. Homogeneous mixtures, colloids. Colloids are mixtures in which the particles are between 1 and 1,000 nanometers. Colloids don't separate upon standing, cannot be separated with a filter, and do scatter light. The only way to tell the difference between a colloid and a solution is through the Tyndall effect. If a light is passed through a colloid, the light will scatter. If a light is passed through a solution, the particles are so small that they will not scatter the light. The only difference between a colloid and a solution is that the particles in a colloid are slightly bigger than that of a solution. Examples of colloids are fog, smoke, foam, jello, butter, whipped cream, egg whites. The Tyndall effect is a procedure of determining whether a mixture is a solution or a colloid. A beam of light is not visible in a solution, while in a colloid it is visible. If you shine a light past a solution, the particles are so small that they will not scatter. You will not see any sort of light in that column or that beaker or that graduated cylinder of your solution. However, because the colloid particles are slightly bigger, they will start to scatter the light, and you will be able to easily see that light scattered in that colloid. Heterogeneous mixtures, suspensions. Suspensions have particles that are larger than 1,000 nanometers. They can often be seen with the naked eye. Suspensions can easily be separated with a centrifuge, can be separated with a filter, and they also scatter light because their particles are so large. Examples of suspensions are paint, salad dressing, orange juice, ketchup, and any mixture that states shake before using. Separating blood. Blood is separated by spinning it in a centrifuge. A centrifuge is a machine that rotates at a very fast rotation per minute that allows heavier particles to migrate towards the bottom while lighter particles rise to the top. Blood can be separated into plasma, white blood cell platelets, and red blood cells. This diagram, or concept map, shows how matter can be divided into its different classes. Here we have elements, compounds, and mixtures like we saw at the beginning of the slides. Mixtures can be divided into homogeneous and heterogeneous mixtures. Heterogeneous mixtures can be defined as suspensions, and homogeneous mixtures can be defined as solutions and colloids.